Today we're going to talk about the migrate classic Ethernet environment to VXLAN BGP EVPN. When migrating a brownfield network consists of connecting existing brownfield network based on the spanning tree protocol VPC and fabric path technology to a newly deployed VXLAN BGP EVPN fabric with the goal of migrating applications or workloads between those environments. Let's talk about what comprise the migration methodology. So first, we design and deploy the new VXLAN BGP EVPN environment like the greenfield. So integrate between the existing data center network infrastructure we call brownfield network, and the new VXLAN BGP EVPN fabric. So the L2 L3 connectivity between the two networks is required for successful application and workload migration across the two network infrastructure. To migrate workload between the brownfield and the greenfield network is likely this application migrate process takes several months to complete, depending on number or complexity of applications migrating. The communication between the greenfield and brownfield network across layer 2, layer 3 connections that are established in the Pierce lab. Go back to see my previous video, and were used during this phase. So we already performed the steps during the greenfield deployment scenario and established L3 connectivity using the VF Lite. Next, we'll configure two connections from the leaf 1 and leaf 2 to the external router here. And this connection is for a layer 2 connection using the VPC domain. The VPC domain is configured on the leaf 1 and the leaf 2. For the server 4, the first hop gateway resides on the external router. So we configured L2 network on both leaves during the migration for reachability through the L2 links. Then we'll deploy L2 network on both leaves. When we move workloads to the leaves, we then convert the network to L3 with Anycast gateway residing on the leaves. So gateway Anycast is the next phase. Instead of moving server 4 to the leaf 1, we connect the server 5 on Ethernet 1/7 on leaf 1, which is the same network of the server 4 to simulate the migration, right? So this is going to be the new server 4. So what we have to do is to create a VPC interface, much like an access interface that I modified and deployed in the previous lab. This will focus on creating a brand new logic interface. I create the VPC interface from side 1 leaf 1 and side 1 leaf 2 VPC. Let's go back to my fabric. The fabric or click is the side 1 greenfield fabric. Go to interface. We're going to create VPC interface. What creates is a VPC pair is side 1 leave 1 and side 1 leave 2. Leave the VPC ID 1. Peer 1 port channel ID 1, port 2 channel ID 1. That's fine. And we're going to type the interface on both leave 1 and leave 2. That's going to be 1/6. 1/6 is a VPC. We want to uncheck BPDU. Take false. Is not port fast, goes to a router, and we're allowing VLAN 2020. Click save. And deploy. To give it a VLAN in VPC1, deploy this. Close it right now. Go back to my side 1 greenfield. Go to interface. We're gonna search interface equals to VPC1. Here you go. You can see it right now. So this is my VPC1 I created, which is the VPC1. The interface 1/6 is created here. The next step is to create an L2 connection between VXLAN, EVPN, and the external fabric. We were going to create a L2 connection. So what I have to do is go to this fabric, external L3 fabric, and find out the ports 1/2, 1/4, and we'll make is the port channel. Make it a port channel. Click the fabric. Same thing, go to interface. We're creating the interface. Action, create an interface. It's gonna be a logic interface, so I have to create. Leave the file1 called generated. Member interface E12 and E14. The port channel mode, we want to use the active BPDU guard, no. Port fast, no. Our channel is VLAN is 20. Okay. Save. Deploy. In the port, let's now log on to my leave 1. Side 1 leave 1. We'll show VPC. VPC is showing the port channel 1 is up and successful. We'll then close this. We wanted to find out the port 1/7, this port 1/7, and make it ready for my migrate server 5. Close side 1 green field and go to interface, make the interface 1/7 ready. Interface Ethernet 1/7. Let's find out side 1, leave 1, side 1, leave 1. Click this, and action is to add it. This is gonna be my access port. And save it, deploy. All right, close. Next, we're gonna create an L2 external network within the VXLAN fabric for the migration. Let's click SD-WAN. On the top of the navigation bar, go to network. Click create. Create a network called external network. L2 only, let's check. Network ID is automatically generated. Keep it default. VLAN ID is 20. Click create. Now create it. Let's double click on newly created the external network. Network attachment. We're going to attach to network. Is called external network. We're going to attach to side 1 leave 1, side 1 leave 2. So let's go ahead, find out the side 1 leave 1 and side 1 leave 2. And we're going to configure side server 5 to migrate a workload to leave 1. So we're going to add it. We're going to attach 1 for side 1 leave 1, side 1 leave 2. So let's attach. We're going to find out side 1 leave 1, side 1 leave 1, and find out the switch. Only the switch, and port is 1/7, which is the access port with deploy list. Okay, save it. Okay. Gonna select these two pending switch and deploy. Manually side 1, creating a new network. Okay, deploy. Right, when it's deployed, we'll log on to side 1 leave 1 and show MAC address table. We can find there's a host connected to my Ethernet 1/7, which is my server 5. One is connected. So let's take a look why I cannot ping anymore. Server 5, that's right. I've been searching about this, why I cannot ping the 20.1 is gateway on the external router. That's thing I have to figure it out. So this is we're going to find out why. We're going to go to the external L3 fabric, go to interface. I'll check my interface to the fabric from the external L3 external router is configured correct or not. So we'll find out that interface port channel via 1. But clearly, I think I missed allow trunk, allow VLAN 20, and native VLAN should not be here. Click save. Deploy it. Correct config. And I can go to the router, external router. Here, I configured differently than expected. Let's do it correctly. Corrected it, and I think after this I can ping the gateway from server 5 to external gateway, gateway in external L3 extension, external L3 fabric. Let's go to server 5 and ping it again. Now it's ping reachable. Now what I have to do, keep the ping running and enter VLAN 20 shut. We want to shut it down. Now the ping failed a few times, becomes unreachable. After we enable overlay in the VXLAN EVPN fabric, the Anycast gateway will be configured on in my fabric. So still close this. We configure already. Double click SD-WAN, go to network. External network will show up right here. Edit. Uncheck L2 only. We're going to enter an IP for gateway and save. Take action and deploy. As you can see, this Anycast gateway will be deployed to Site 1 Leave 1 and Site 1 Leave 2. So this is gonna be the mistake I did. After that, ping started again. Ping started again. So for the real migration, I do not need to configure everything as I did in this lab, as the network in the VXLAN EPL already exists, are created and associated to the interfaces. I only must configure the leave port to the right VLAN which can connect to the server once for migration and for each VLAN I migrate. Then I test if I can ping the gateway to validate the L3 extension. All right. Allow me to take you to know and other good stuff. We call it EPL. So EPL stands for endpoint locator. So we'll have to enable endpoint locator feature in the NDFC, which helps us locate endpoints that are connected to the leaves. This is useful when we have to troubleshoot or locate one from hundreds of endpoints inside my data center. The EPL endpoint locator feature allows real-time tracking of endpoints within the data center. So this includes tracking the life history of an endpoint and providing insights into the trends associated with endpoint addition, removal, or moves, etc. So endpoint locator EPL feature relies on the BGP pair established between the NDFC and the RR. So after established the BGP session, NDFC receives the BGP updates from the RR. Everything is RR. This is RR. RR on the spine is RR. Okay. After established the BGP session, NDFC receives BGP updates from the RR with endpoint information. Endpoint locator provides almost real-time tracking of every endpoint. Events such as endpoint coming up, endpoint going down, and endpoints move are now visible with a few simple clicks. So I will bring you to know this feature. We'll first connect to the leaf 7. We'll configure a port. The port is on my leaf 2 is a 1/7 Ethernet 1/7, and this port is connected to my NDFC. Okay, it's connected to my NDFC, adapter NDFC. So close this, and we'll go to the menu, and we'll go to MSD fabric, and we'll have to go to interfaces. We find out device name equals side 1 leaf 2. That's future. And we'll have to take care of Ethernet ports 1/7. Find out this interface, exact interface, and we'll have to add it. Okay. Click Edit. It's connecting to my NDFC. So, policy. The policy is not a trunk, it's not access, it's called an EPL route interface. Okay, select this. It's gonna be L3 interface. Give IP. Go down, go down, go down. Here, freedom config. IP router, OSPF underlay area 0, area 0. We advertise it into OSPF. Double check. Okay, put it in service in the OSPF. That's deployed. After deploy this, let's close this. Interface in sync. Let's now log on to my fabric green field. Side 1 green field, we're going to take a fabric overview. Under action, here we're going to choose deploy configure endpoint locator. In the endpoint locator dialog, let's check in my fabric, configure my fabric, and in the spine route refactor RR1, we're going to choose take a drop down we're going to select spine 2 as RR. That's it. And do you want to collect additional information, port, VLAN, etc.? Say of course yes. Let's save the config. After a couple of minutes, a recently configured endpoints locator populates the endpoint activity screen. Then the two endpoints are server 1 and server 2, located on the leaf 2 and leaf 3, located to leaf 1 and leaf 2. If I do not see both endpoints, we're going to ping from the server 1 and ping from server 2. The reason that I might see that one endpoint is because the two hosts are in the same subnet, and one of them will do ARP. It can enable suppress ARP or ping the gateway for an ARP request from both endpoints. So in this case, let's log on to site 1 RR, which is the spine 2. Let's show BGP L2 VPN EVPN summary. Let's verify a new BGP session with the NDFC IP. For the EPL feature is enabled right here. I can see this neighbor, and that's enabled, tells me enable EPL. Close this. We're going to analysis, and for endpoint visibility, scroll down here. We can see, scroll down to the list of endpoints. Okay, that's needs a while. Let's go down to the list of active endpoints table. Then we're gonna click 192.168.12.22, which is the IP of my server 2. And we're going to click it. Scroll down here, endpoint life. That shows the endpoint IP of 192.168.12.22. Leaf 1 and my leaf 2. So that's all about Cisco Nexus Dashboard Fabric Controller for VXLAN EVPN multi-site deployment. If you have a question, any question, leave a comment below. Alright, thank you guys for watching this series of videos about Cisco Nexus Dashboards in the NDFC. Hope you like it. See you next time.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.